All right. Let's go ahead and get started. So basically, here, hold on, let me do this. I think what I do is a filled in, maybe white, and maybe I'm smart. All right, I'm giving myself some space to work here. All right, so check this out. If you have a situation where you got x equals, and you can write this down real quick, but x equals 2t minus 1 and y equals t squared plus 5. And we're going to be between -4 and 4. So as before, we're going to create our 3 column table where we're going to have t first, then our x value, and then y. -4. -4 to 4. Try to give myself. No, we're gonna go through all of them. I mean, probably a good idea. I mean, you could, just as long as you have a decent idea of what's going on. All right, so let's walk through these real quick. So we got -4, -3, -2, -1, 0, 1, 2. And am I doing too much? Probably, but I still want to make sure that you got a good idea of what all is going on here. So we got 3 and 4. All right. All right, if I plug -4 in here, and this is a good time to have like a good calculator that you can kind of just set up and let it roll. As a matter of fact, if you have a TI-84, what you can do is you can do y equals 2x minus 1, and then just create a table. It will automatically give you all the values you want. Just saying. All right. Actually, so if you have any calculator that gives you table values, it'll automatically do that for you. All right, so let's walk through this. -4 times 2 is -8 minus 1, -9. -3 times 2 is -6 minus 1, -7. And here's what we should know. This thing is linear, right? And its slope is 2, which means I'm just going to be going up by 2 each time, right? So at this point, we just use that fact to help us out, fill the rest out. Real simple. Now with the y value, we're going to square and then add. So we're going to square -4, which gives you +16, plus 5 is 21. Second thing was -3. -3 squared gives you +9, plus 5 is 14. -2 gives you +4 plus 5 is 9. -1 gives you +1 plus 5 is 6. 0 gives you 5. 1 gives you 6. 2 gives you 9. You should see the pattern emerging at this point. And that makes sense because you have t squared, which is a what kind of shape? Parabola, exactly. It is definitely a parabola. All right, so now we're going to try to plot these. Now, I'm not even going to start with the first two because they're not, or the last two because they're not even on the thing. So I'm actually going to start with -2. So when t is -2, x is -5. So -1, 2, 3, 4, 5, -5 right there. and then positive 9. So this is 9 right here. So I'm going to try to think that should be about right there-ish. All right. And so basically what we can say is when t equals -1, we're at that point right there. All right, when t is equal to -2, your x value is -3. So 1, 2, -3. And your y value is +6. So 9, 8, 7, 6. So somewhere right about here-ish. Then let's see, when t is equal to 0, you have -1, +5. So like right about there. When t is equal to 1, you have 1, 6. So right about there-ish. And then you have 2 when t is equal to 2. X is 3, y is 9. So gotta back up here. Like, oh, 3, so 1 over. And that's kind of just a guesstimate there. And it should pretty much look like a parabola. Where that's t equals -2, t equals -1, t equals 0, t equals 1, t equals 2. That's it. So just like before, let's go back through the steps. You start with your table, plug in your t values, and go from there. Real simple. Shouldn't be too bad. All right, let's do another one. All right, same deal here. We got x is equal to 6 sine t, and you have y is equal to 6 cosine t. Hey, let's try to stay focused. Now, just looking at this thing, can anybody guess what shape it'll probably end up being? Absolutely. All right, for this one, since we have sine and cosine, what do you think some values? Exactly. Yeah, probably not a good idea to do that. So we're still going to create our values here, x, y. And then we're going to go through the whole gambit. So we'll start with 0, then pi over 2, then pi, then 3 pi over 2 should be good enough. And of course, 2 pi would be the same as 0, hopefully. All right, so what we're going to do here is we'll say, okay, if I plug 0 in for x, you plug in 0 for your x value, what do you get? 0. If you plug 0 in, if you put pi over 2, so sine of pi over 2, that's going to be 1 times 6 is 6. If you do pi, sine of pi is 0 again, so times 6 is 0. And if you do 3 pi over 2, you get -1, so -6. Same difference with your y value. You probably guys know where this is going, right? Starts with 6, 0, -6, 0. And this is pretty much how all of them are going to be when you see like the sine and the cosine side. But be careful, guys. Be careful, be careful, be careful, be careful. The reason why you want to be careful here is because, look, note that we're told that y is equal to 6 cosine of t. Just because it's the y value doesn't automatically mean that it's going to yield you a y value on the unit circle. Be careful about which one goes with which, because think about it like this. Right, exactly. No, they're flip-flopped. Normally, x equals r cosine of theta, right? But in this case, they're switched. So be careful, because one will give you something like this versus one giving you something like this. Here, it doesn't matter because it's a circle, right? But depending on how they set it up, one is going to give you a ellipse that's elongated this way, or one might give you an ellipse that's elongated this way. So be cognizant of that. Does that kind of make sense? Okay. Just be careful is all I'm saying. All right. So let's do this real quick. This should be a real simple one. You got 0, 6. So 1, 2. So 0 and then 6. 1, 2, 3, 4, 5, 6. And this is at t is equal to 0. And then we got 1, 2, let me see, 0, 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This is t equal to pi over 2. 1, 2, 3, 4, 6. And t equal to pi. And then 1, 2, 3, 4, 5, 6. T equal to pi over 2. And it's not what I was trying to do. I'm gonna try one more time, and then I'm gonna try to draw it myself. How do you use this thing? Okay, never mind. Okay, like this. Ah, smart. Boom. Yay. Thank you. All right, everybody cool with that? Questions? All right. All right, let's get into some of the nasty stuff now. All that was fun and easy. Let's get into some of the hard stuff. Now, I think you all can figure out the rest pretty much for at least that part of it in terms of the graphing. So I'm gonna leave you to this one. We're gonna do, yeah, we're only doing the first 12. So I'm gonna leave you to 3. I'm not gonna cover 3, but I am gonna do 4 and then something a little bit harder than 4. All right, so in this particular situation, all right, remember, we've only been doing parametric equations here. We've only been doing parametric equations, which, remember, parametric equations means you have two equations with a parameter, and our parameter here is which variable? What's your parameter variable that each side's in terms of? T, thank you very much. All right, both of them have the parameter t, but we can turn this from a parametric equation into a rectangular equation. Rectangular equations only have two variables. Which variables are they? X and Y. Remember how we were able to turn polar into rectangular? We can turn parametric into rectangular as well. Y'all following me so far? Now here's how you do it. Here are the steps. First, solve for t in one equation. All right. 2, plug in. That's it. So let's take a look at this. We've got x is equal to 2t minus 1, and then we've got y is equal to t squared plus 4. All right. Now, in this particular situation, which one of these do you think is going to be easiest to solve for t? X, absolutely. And if we solve for t here, we get, let's see, you got x plus 1 equals 2t, and then you end up with t is equal to x plus 1 over 2. Should be real simple, real easy. I'm stalling so you can have it. Make sure that you got it down, all that good stuff. All right, and now since we have x in terms of t and we want rectangular, we can just plug it into the other one. And when we do that, it's going to look like this. Y equals x plus 1 over 2 squared plus 4. It's just substitution. And I mean, we could go further if we wanted to. We could end up with something like y equals x plus 1 squared over 4 plus 4, right? And then I'm trying to get it to something that we can kind of use here. And then what could I do? I'm trying to get x plus 1 squared by itself. What could I multiply by to get rid of the fraction? Yeah, we'll get there, but what could I multiply by to get rid of the fraction? 4, exactly. You know, 4y equals x plus 1 squared plus 16. And yes, square root, or I could square root, but also what if I wanted to just get x plus 1 squared by itself? Subtract 16. So I end up with x plus 1 squared equals 4y plus 16. Or even if I wanted to be even cleaner, I could factor a 4 out of the left side, and that would finally give me a final answer of x plus 1 squared equals 4y plus 4. Yes, minus 16, my bad. You are correct. Yeah. Ooh. No, it doesn't like me. Okay. Here's what we're going to do, just to make it look ugly. Here we go. All right. What does this have to do with anything? What equation is that? What conic is it? It's a parabola. Why? Yes, but what characteristics of this equation show that it's a parabola? Yeah, you're one thing squared, one isn't. X is squared and y isn't. As a matter of fact, it's a parabola that opens up, whose p-value, by the way, is what? 1. Whose p-value is 1. And if we wanted the center, we could figure out that the center is -1, 4. And we could graph it if I asked you to, but I didn't ask you to. So, but I'm just saying, this is the idea, is that you start with something that is parametric, and then you turn it into something that's rectangular that you can use, is the key. All right. Now let's get into something that's difficult. All right. So this is the last one I'm gonna do today, and then I'm gonna let y'all have the rest of the period, even though we don't have much time left. Let's look at 6. All right, it says turn into a rectangular equation. Ew. We got E. Ew. All right. Now, but it's still the same. What are the only two things that we have to do here? So solve for T and plug in. Which one is probably going to be easier to solve? X. We got X is equal to E to the T. How can we deal with this? Does anybody remember? Natural log. Thank you very much. You end up with ln of X is equal to ln of ET. All right. Just a little Spielberg humor there. All right, we got ln X is now equal to what? T. E and ln, remember, cancel each other out. So it makes things real easy for us. So now what we can do is we can say y equals E to the 2 ln X. Because all I'm doing is taking ln X and plugging it in where T was. This is your answer. Yep. That easy. All right, we're not done yet. Hold on. I lied to y'all. We're not done. Because 8 and 9 are kind of nasty, but I'm gonna go through 8 real quick. All right. For problem 8, we have a situation, bless you, where it's gonna be a pain in the behind to try to figure out to solve for t. Would you all not agree? Because you're going to end up with cosine inverse or sine inverse, and we don't like those. So what we're going to do instead is use something that we didn't know, is the fact that sine squared theta plus cosine squared theta equals what, guys? 1. So since we're going to use this, here's what I'm going to do. Instead, guys, I'm going to say, okay, I got x is equal to 5 cosine of t, right? So if I divide by 5 on both sides and then square both sides, I get cosine squared of t. That should be pretty simple enough, right? Divide by 5 on both sides and then square both sides. That's all I did. The same thing with the y value. You got y equals -2 sine of t, and then you end up with y over -2 is equal to sine of t, but we're going to square it. I hate you, Scam Likely. All right. And the unit with y squared over 4 equals sine squared of t. Everybody follow me so far? All I did was solve for cosine of t and solve for sine of t. That's all I did. And then squared both. So I end up with squared part. So what we'll end up with if I plug everything in is y squared over 4 plus x squared over 25 equals 1. And what is this, by the way? Ellipse. Why is it ellipse as opposed to hyperbola? There you go. It was a good guess. Yeah. All right, that's it. Now, I will give you a hint on 9, even though I'm not going to do it. 9 will end up being a hyperbola. You're going to need to use a different Pythagorean identity for that. One that involves tangent and secant. And that's the only hint I'm going to give you. Other than that, guys, that's it.